Hello, we are going to go over your laws of exponents. When multiplying bases, you keep the base and add your exponents. Okay, that was close enough on there. So, for example, let's say we have this setup. First of all, you're going to multiply your coefficients normally. So 3 times 4 is 12. Then we're going to that was a long bell. So then we're going to work letter per letter. You can't combine different bases. So we're going to go to the x's. For your x's, you are going to do x to the 2 plus 3. Then you're going to go to the y's. Now, there's a y in your first bubble, but not in your second bubble, so you're just going to leave that as 5. On to the z's. You do need to know that when you don't see an exponent, there is a hidden 1 there. So this would be 1 plus 2, and we get 12 x to the 5th, y to the 5th, z to the 3rd. If you would like, you could write this as 12xy in parentheses 5 z cubed. The next one up is when you are dividing bases. When you divide bases, you're going to keep the base the same, and you're going to subtract your exponents. Oop, okay, that's close enough. Just remember to do the numerator minus the denominator. So in this case, you're going to do 12 divided by 2, divide the coefficients normally, and then you were going to subtract top minus bottom. So we have 8 minus 2. Remember that this is a 1 here if you don't see it, so it's going to be 2 minus 1. And the z, you don't see any other z's, so you're just going to leave it as is. This is 6x to the 6th, y to the 1st, z 3. On to the next one, the power to power rule. When you have an exponent to another exponent, you keep the base and multiply your exponents. Sometimes you have to distribute the exponent to everything on the inside. And if you have a fraction, then the exponent distributes to the top and the bottom of the fraction. So you keep the base and you multiply the exponents. So in this particular case, we have a 3 on the outside. So you're going to distribute it to everything on the inside. And you're going to do that through multiplying, except notice how this 2 out front has a 1 as an exponent. So this is 2 to the 1 times 3. Now this is a 2 for the x, so 2 times 3 is 6. This is a 1. 1 times 3 is 3. And then for the z, 5 times 3 is 15. Your other case is if you had x squared over y to the 5th cubed. You need to distribute the exponent to the top and the bottom to get 2 times 3 is 6, and 5 times 3 is 15. Oh my gosh, we have a lot. By the way, you do have to remember all of these rules for the next time we see each other. So the next one is negative exponents. Negative exponents create fractions and they get rid of them. So if you're starting with a whole number, the negative exponent creates a fraction. On the flip side, if you're starting with the fraction, the negative exponent gets rid of the fraction. You do have to distribute the negative to everything on the inside of the parentheses. But notice how in the last example, the negative is only attached to b. A has an exponent of 1. So the a stays where it is, and the b is what moves because the b has the negative exponent. So you change the location and the sign of the exponent. What that means is, let's say that we're starting with 2 to the negative, I don't know, let's go with x actually. X to the negative 2, that is going to become 1 over x squared. If you have 1 over y negative 3, that's going to become y to the positive 3. So a negative exponent in the first case created the fraction, and in the second case, the negative exponent got rid of the fraction. If you have, let's see, x, y, negative 2, and we'll put, I'm just going to go here. This turns into 1 over, because of the negative, xy positive 2. And from there, you could distribute the exponent to get x squared, y squared. If you have a case like this, you're going to move everything that has a negative. So, for example, let's put a 3 in front there too. Let's go with a different number. What's a different number? 4. So you're going to keep everything without a negative where it is. My x squared doesn't have a negative, and my 4 doesn't have a negative. So I'm going to write it exactly as is, as x squared over 4. Now I'm going to look at my negative pieces. So my first negative piece, y, negative 3, has a negative. It's in the numerator, so I'm going to put it in the denominator. My next piece, z to the negative 5th, it's negative and in the denominator, so now it's going to go to the numerator and as a positive. Going on to rational exponents, you do need to remember power over root. Oh boy, let me try this again. There we go. Power over root. You also have to remember that the square root of x is equal to 2 square root of x, which is equal to x to the 1/2. Hey, that wasn't that bad. So, if you were to have x to the 3 over 4, 3 is the power, 4 is the root. So this is equivalent to x cubed, and then take the 4th root of it. Now in this case, I cubed x first. However, you could take the 4th root first. And then you could cube x. So the exponent could be on the outside or the inside, it doesn't matter. Also really important, make sure you're writing the 4 very, very tiny. If you were to have the square root of x to the 5th, you need to know that your power is 5 and your root is 2. If you don't see a number there, you do need to know that that value is 2. So this is the same as x to the 5/2. And sometimes you have to distribute the root. So if you had, let's say, the 3rd root of x squared y cubed, and then we have, let's say, 27. Now your root is 3. So this is 27 to the 1. The exponent here is 1. The root is 3. Now x has an exponent of 2. Your root is 3. Y has a power of 3 and a root of 3. If you put the cubed root of 27 in your calculator, or just 27 to the 1/3, you would get 3. You can't simplify 2/3, but 3 divided by 3 is 1, which is just y. And 0 exponents, anything to the 0 power is 1. So, I tried. You know what? I tried. Anything to the 0 power is 1. Notice how you would distribute the 0 to everything on the inside, so everything becomes 1. But in the very last case, without parentheses, the a has an exponent of 1, only the b has an exponent of 0. So the b becomes 1, which then you're just left with a. So for example, if you had 3 to the 0, that is 1. If you had 4x squared y to the 0, you would distribute a 0 to everything on the inside, and ultimately you get 1 for everything. But if you had 4x to the 0, because there's no parentheses, you can't distribute, and that means only the x becomes 1, which leaves you just with 4. All right, solving equations with fractional exponents, that means if you have this. If you have something like this, you're going to isolate the base, you're going to get rid of the 2, and you get x cubed equals 27. You're going to raise it to the reciprocal power, which is 1/3. And in your calculator, 27 to the 1/3 is just 3. So x would equal 3. In this case, you would have to divide by 2 first, and you would get x to the negative second power equals to 16. And then if you have a negative 2, your reciprocal is negative 1/2. So if you plot that in the calculator, 1/2 represents the square root, and the square root of 16 is 4. But because it's negative, you're going to flip it, and you're going to get an answer of 1/4. Moreover, what you have to be really careful about is if your denominator is even, you need a plus or minus. You see, in the last one, the denominator was odd, so there is no plus or minus. So your answer is actually plus or minus 1/4. Going on to the next one, the graphs of exponential and log functions. You do need to know that exponential functions, y equals ab to the x power, looks like this. Your domain is all real numbers from negative infinity to infinity. Your range is typically from 0 to infinity. It's really from your asymptote to infinity, because you do have an asymptote, and your asymptote is y equals. And it is always either increasing or decreasing. We're going to talk about how we know when it's increasing or decreasing really quickly. Sorry, this is becoming a long video. Next is your log functions. Log functions, such as y equals log base 2 to the x, for example. I also want to point out the coordinate here, the y-intercept is 0, 1. Now here, log functions look like this. They're hunched over. Now, your domain, you do have an asymptote. Your asymptote is typically, this is a vertical line, so your asymptote is typically x equals 0. So your domain now is from 0 to infinity. Domain is x values, range is y values, by the way, left to right versus up and down. Now, your domain is really from your asymptote to infinity. Your range is all real numbers. Goes always up and always down. Your key features are that your asymptote is x equals. And that's kind of all I got for log. Oh, yes, I do have one other point. Exponential functions have y-intercepts. Logarithmic functions have x-intercepts. That typical x-intercept, unless there's a transformation, is usually 1, 0. So notice how one is 0, 1, and the other is 1, 0. That's because exponentials and logs are inverses of each other. They're inverse functions. I think this is it. Okay, we're going to cover that really quickly. Exponential growth versus exponential decay. We remember this, hopefully. A is your initial value, and B is called your growth factor. It is also your base. Now, if your growth factor is greater than 1, you are increasing. If your base is less than 1, but also greater than 0, you are decreasing. So increasing functions go upwards, whereas decreasing functions go downwards. They still have the asymptote. R is called your rate. So your factor is the entire base, and your rate is just how much you went up and down by. So for example, if you have y equals 1.2 to the x, your factor is 1.2. Your rate is just 0.2. You went up by 20%. Now, if you had y equals 0.8 to the x, that's less than 1, so you're decreasing. Let's see, your factor is 0.8. Because it's less than 1, you're decreasing, and your rate is how much you went down by. If you started at 1 and you are at 0.8, then your rate is 0.2. You went down by 20%. So you need to know, how do you know if you are growing, and how do you know if you are decreasing? You also need to know that exponential functions have y equals, logarithmic functions are x equals. Sorry for such a long